For most of human history, the reason for the sky's color remained a mystery, despite it being a daily observation. There is no physical ceiling or painted surface above the Earth. The sky is a continuous physical reaction happening right in front of our eyes. In the 1600s, Isaac Newton demonstrated that sunlight is polychromatic, a continuous spectrum containing every visible color. Outside our atmosphere, light travels in straight lines with no particles to hit, leaving the vacuum of space pitch black. If sunlight is a mix of every color and space is black, something inside our atmosphere must be isolating the blue wavelengths. Solving this required scientists to stop looking up and start tracking the physical journey of light. In the 1860s, John Tyndall attempted to solve the puzzle by shining light through smoke and dust in his lab. He discovered that small particles scatter shorter wavelengths of light more effectively, a phenomenon now called the Tyndall effect. However, Earth's atmosphere lacks enough ambient dust to account for the entire sky changing color. Tyndall's experiments were accurate, yet his explanation remained incomplete. Science needed a deeper theory. In the 1870s, Lord Rayleigh made a genius conceptual pivot. He considered if the obstacle was the transparent air itself. Most of our atmosphere is composed of 78% nitrogen and 21% oxygen. These specific gas molecules are significantly smaller than the wavelength of visible light. This turns the atmosphere into a dense molecular minefield for incoming sunlight. Rayleigh scattering occurs when electromagnetic radiation interacts with particles significantly smaller than its wavelength. This chart illustrates Rayleigh's law. Scattered light intensity increases dramatically as wavelengths get shorter. Red light has a long wavelength, passing through with very little scatter. Blue light has a shorter wavelength, scattering 10 times more strongly, bouncing in every direction. When you look up, you see this ricocheting blue light reaching your eyes from every direction in the sky. Based on this math, violet light has the shortest wavelength and should scatter the most. Yet the sky does not appear violet. The sun emits less violet light to begin with, and the upper atmosphere absorbs a portion of it before it reaches our eyes. Human photoreceptors are also less sensitive to violet light, causing our brains to interpret the sky as blue. The color we see is the result of human biology filtering these physical interactions. At sunset, sunlight travels a much longer path through the atmosphere, scattering all the blue light away and leaving only the longer red wavelengths. Distant mountains look blue because the volume of air between the viewer and the peak scatters blue light into the line of sight. Clouds remain white because they're made of water droplets, too large for Rayleigh's law. They scatter all wavelengths equally in a process called me-scattering. The blue sky above us is a continuous mathematical illusion, shaped by collisions and decoded by the human brain.